Hello students, in this class we are going to discuss one more named reaction of aldehydes and ketones, that is Wittig reaction. Okay, and this reaction involves the conversion of aldehydes and ketones into corresponding alkanes. Okay, and we can write this reaction involves the treatment of aldehydes and ketones with phosphorus ylide. The reaction involves the treatment of aldehydes and ketones with phosphorus ylides to form alkenes. Okay, to form, otherwise here I will write alkenes. See, whenever the aldehydes and ketones are treated with phosphorus ylides, they will give the corresponding alkenes. And here I am writing the general reaction, and we know that this is the carbonyl group, and here if R and H are there, then it is an aldehyde, or on both sides if R and R dash are there, then it is a ketone. Therefore in general we are writing this one for aldehyde or a ketone when it is treated with phosphorus ylide, which is having the formula of H2C P C6H5 3, and here this CH2 is having a negative charge and this P is having a positive charge, correct? And we can write this one like this also, H2C double bond P C6H5 3. This is a phosphorus ylide, okay. And in some notes this C6H5 is also writing like C6H5 is also writing like a pH. That is also correct. In place of C6H5 they are using pH, that is a phenyl ring. That is also correct. Okay, when aldehydes and ketones are treated with phosphorus ylide, we will get a alkene plus C6H5 3P double bond O. This is called triphenyl phosphine oxide. Triphenyl phosphine oxide, and this one is a alkene. This is the reaction which is called Wittig reaction. The reaction which involves the treatment of aldehyde or ketone with phosphorus ylides to form alkene is called Wittig reaction. See here what happens. This oxygen is combining with this phosphorus, or otherwise we can write like this phosphorus, and this CH2 will combining with this carbonyl carbon of the aldehyde or ketone to form alkene. Okay, take some examples for this one. Some examples for Wittig reaction: CH3 C double bond O H. This is acetaldehyde. When it is treated with CH2 double bond P C6H5 3, we will get CH3 CH double bond CH2 plus C6H5 3 P double bond O. This is propene, correct? This is propene. See here, this carbon double bonded oxygen is there na, and this oxygen is now combining with this phosphorus with the double bond to form an oxide, phosphine oxide, and this CH2 group will now replace this oxygen and it forms double bond with this carbon. It is CH3 CH double bond CH2 propene. Okay, or we can take another example for ketone CH3 C double bond O CH3. This is acetone. When it is treated with CH2 double bond P PH3. Now I will write this phosphorus ylide by this penyl symbol, that is PH, and here we will get CH3 CH3 C CH3, correct, CH3 C CH3 double bond this is CH2 correct. Then now this PH3 P double bond O phosphine oxide. This is 2 methyl propene. On second carbon methyl substituent is there, therefore it is a 2 methyl propene. Okay, this is the Wittig reaction. Coming to the mechanism, reaction mechanism of Wittig reaction, it involves the following steps. Only 2 steps are there here. Step number 1 is what? The negative carbon of the ylide, YLIDE, the negative carbon of the ylide attacks the carbonyl carbon to form a betaine. See here in the reaction what we have written, this phosphorus ylide with the CH2 having a negative charge and this PC6H53 having positive charge. This will now attack on the carbonyl carbon of the aldehyde or ketone to form one intermediate compound that is called a betaine. C double bond O plus CH2P C6H53 plus minus. This is what? Ylide, phosphorus ylide. And we know that in the carbonyl groups, this oxygen is having partial negative charge, it is having partial positive charge, and therefore it will drag its bonded pair of electron towards its own oxygen. This oxygen which is having more electronegative character will drag the pi bonded electron towards itself and it becomes electron deficient. Then now this negatively charged CH2 group will attack on this carbon, and here we will get a C O minus, correct? Then this one CH2 P plus C6H53. This intermediate is called betaine. And the second step of this mechanism is what? The betaine undergoes elimination of triphenyl phosphine oxide. The betaine which formed in the first step undergoes elimination of triphenyl phosphine oxide to give the alkene. See, this is minus CH2 single bond P plus C6H53. This is betaine, and here these two opposite charges, okay, and they can form bonds between themselves, and here we will get CO CH2 P C6H5 3. This positively charged phosphorus will form a bond with the negatively charged oxygen, and here we will get one bond. And this cyclic intermediate, the cyclic intermediate is called oxaphosphatane. Oxaphosphatane, okay, and it is unstable, and here bond rearrangements will take place to give alkene and triphenylphosphine oxide. See, this bond will shift towards this oxygen phosphorus single bond, and this phosphorus will now break this bond, and this bonded electrons will move towards carbon carbon single bond, and here we will get a C double bond CH2, that is alkene, correct, plus C6H5 3, the C6H5 3, P double bond O, this is triphenyl phosphine oxide. Okay, this is the reaction mechanism of Wittig reaction. Thank you.